Video we talk about support vector machines. Okay, this is not any particular machine, it's although it's called a support vector machines. So support vector is something which we'll talk about it. So this is a supervised machine learning algorithm, and it's mostly a classification algorithm. Okay, so it can be used for both classification and regression though. So the objective is to when we have a set of data points and they belong to two different classes, like let's say these are some positive samples and these are some negative samples, we want to find a plane, we call it in a hyperplane, which will separate them into two separate groups. So let's say we can have different types of lines here. Let's say this is a blue line, there's a black line, there's a red line. All are separating the positive and negative points. But what we want to make sure they are very solidly grouped into two different groups, and when a new data point comes, it's very easy to identify whether it should go to the negative side or the positive side. Okay, so the example, we let's say this is a better classification or a better hyperplane positioning with respect to this arbitrary ones, where this green line is the hyperplane and the red lines are kind of equidistant from the green line. Okay, so this is the green line is called the optimal hyperplane, and this is separating the positive and the negative points with the widest margin. Okay, so this is called a maximum margin, this is called a margin. If this side is length d from the green line, this side is also d. Okay, so total is 2d. Now you see this items, this are the called support vectors. Okay, the data item of the group positive samples, data item from the negative samples, which are lying very close to those decision lines, they are called support vectors. So you see the objective, what is the objective? Objective is to find the optimal hyperplane to correctly classify between the data points of different classes. As I said, we want to make sure the support vector machine does correct classification, the errors are less, and the errors will be least when the hyperplane, the width of the margin is higher and higher. So what we want to do, we model it as a convex optimization problem, where we try to maximize the width of that hyperplane. So now hyperplane is a term which is used indifferently. Like if it's a two-dimensional space, then this will be a line. Okay, so the hyperplane dimension is one less than the number of features basically. So if it's a three-dimensional, like it's a two-dimensional place, there are two features. The hyperplane is a straight line. If it's a three-dimensional space, and then hyperplane, like it's like a room and there are some points distributed around this place, and then hyperplane will be a plane which will separate those 2 points in two different groups. So the hyperplane dimensionality is basically the number of features minus 1. Okay, so if it's a 4-dimensional space, then the hyperplane will have 3-dimension item. So the distance between the hyperplane and the first point for all the different classes on either side of the hyperplane is a measure of how sure the algorithm is about its classification decision. What does it mean? It means that the wider the hyperplane is, then it's much better, much easier to classify where a particular point should land, which group it should be classified into. Okay, and the support vectors are the points closest to the hyperplane, as I've already said. Like this is a support vector, this is a support vector, and they determine the position and orientation of the hyperplane. So the support vectors are very important. They determine the position and orientation of the hyperplane. As I said, it's a three-dimensional space, then the plane, how it is organized or oriented is very important. So we have to make sure that SVM is an algorithm where the points are linearly separable. There it works very well. If the points are not linearly separable, that means you cannot just separate with one particular plane. There might be some other way of projecting them in a higher dimension. We'll talk about it later. But otherwise, support vector machine is a supervised ML algorithm, and we'll learn more about it.